This video I'm going to be going over R and S configuration. This is question 5 on the exam. And so we're going to go ahead and assign R and S to these chiral centers. And then after that, we can identify if it's an enantiomer or a diastereomer, or the exact same. So what we're going to do here is we're going to go and look at this carbon right here. Let me make my font a little smaller. And we're just going to notice the 4 different groups attached to it. So we see a carbon, and this is a carbon. And right off the bat, I see a Br. So that's going to be my first priority. Boom. All 3 of the other ones have a carbon attached to it. So I have to go to the next atom that is attached to. See, here I have another carbon. I don't go to the H directly because it's attached to a carbon first, which is higher priority. So this is attached to a carbon. This is attached to a oxygen, and this is attached to this carbon right here is attached to a chlorine. So who wins priority? It's between O and Cl, and if you look at the periodic table, you can see that Cl is the bigger atom, so it takes priority. So this carbon would then take priority number 2. This one would be priority number 3, and then this one would be priority number 4. And quick thing, guys, if the 4th priority is on a dash, R or S, whatever you get, it stays as R and S. But if it would be on the wedge, you would just flip it, and so an R would be an S if it was on a wedge. I think you guys know that already, but just making sure. So here we have 1, 2, 3, just going the stupid way, so that's S. And we see that the 4th priority is on a dash. These are on wedges, kind of like a bow tie. So this would be an S configuration. Okay, looking at this carbon now, we see a Cl and O. This Cl is going to get the number 1 because Cl is greater than oxygen. Oxygen would get the 2nd priority because it's directly attached to an oxygen instead of directly being attached to like a carbon. So oxygen gets the 2nd. Here we have a carbon versus a hydrogen. Carbon obviously wins, and then we have the 4th. This is going 1, 2, 3. This is going the right way, but we see that this hydrogen is on a wedge, so it's actually going to turn into S. So far, these are both going to be S. Now looking at this Fischer projection, we see carbon, carbon, carbon. This is a carbon. Let me actually use my laser pointer. We have carbon, 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 but we have Br, and that's what separates them. So Br is automatically the number 1. Next we have carbon, which is attached to another carbon. We have carbon attached to an oxygen, and then we have a carbon attached to a Cl. And remember that Cl is greater, so that gets the number 2. Number 3 goes to this one because that carbon is attached to an oxygen instead of another carbon, and this one actually gets the 4th priority. So this is going to be 1, 2, 3, which is going S, but because the 4th priority, remember, is on a wedge, it translates to R. This is going to be R. Okay. This last carbon right here, we have Cl, and the rest are carbons except this hydrogen. We can automatically write this hydrogen as 4 and this chlorine as 1 because it has the highest priority. Now we're just between these two. This is a carbon attached to a bromine, which is highest priority, and this is a, oh, sorry. This is not a carbon, this is an oxygen. This is directly attached to an oxygen, and this is directly attached to a carbon. So oxygen automatically wins. Sorry, I thought it was a carbon there. So actually this gets the 2nd priority, and this gets the 3rd priority. If this was attached to a carbon instead, then it was attached to an oxygen, this would win on the top. This would win because it would be attached to a bromine, and this would be a carbon attached to an oxygen, and that one would get 3rd priority. but because it's directly attached to an oxygen, that gets the second priority. So we see it's 1, 2, 3. That is the S way. Oh, sorry, that's the R way. And we see that the hydrogen is on a dash, so we keep it as R. So there we go. So comparing the two, we go from S to R, and we go from S to R again. So both of them switch, which tells us it's in enantiomer. A diastereomer would be like from S to R and from S to S. So one of them stays the same and one of them switches completely. And the same would obviously be S to S, S to S. So that's how to do number 5. And I think it was pretty straightforward. That's basically